My dear students, welcome to Easy BTech, your guide for BTech and beyond. And we are discussing about signals and systems subject. And today's session is problems on Fourier transform. Very important session. Please watch videos regularly, subscribe the channel, share the channel. Let's start our session. Problems on Fourier transform. So let's take the problem. Find Fourier transform of given signal. So we are discussing problems on Fourier transform. So find Fourier transform of the given signal e power at into u of minus t. E power at u of minus t. What is the Fourier transform of this given signal? So how to do? We know Fourier transform of a signal x of t, f of x of t means Fourier transform of x of t is equal to capital X of omega is equal to integral minus infinite plus infinite x of t into e to the power minus j omega t dt. Just integral formula. So the given x of t we take. So x of omega is equal to integral minus infinite plus infinite. What is the given signal x of t? E power at u of minus t into e power minus j omega t dt. So here we think about first u of minus t. It is the step signal, time reversal of step signal. U of t is the unit step function. U of minus t is the time reversal of unit step function or folding of unit step function. So let's see this u of minus t. U of minus t. So first I am drawing u of t. This is the u of t. And u of minus t means folding of u of t. Folding of u of t. So this is the u of minus t. Right? So here t and this will be u of minus t. Amplitude is 1. So t, this is 1 and it is u of t. It is 1. So if you observe u of minus t, the value of u of minus t is 1 for t less than 0. What about t greater than 0? U of minus t value is 0 for t greater than 0. So that is the meaning of u of minus t. As per u of minus t, we are going to solve this integral. Right? So according to u of minus t, the limits minus infinite to 0, t less than 0. That is minus infinite to 0, e power at and u of minus t value minus infinite to 0, how much it is? 1. So e into e to the power minus j omega t, e to the power minus j omega t dt. So here we have basis exponentials, so we can add powers. So x of omega is equal to integral minus infinite to 0 e to the power a minus j omega t. T is a common. Just I have taken t common. So do this integration e to the power a minus j omega t divided by a minus j omega. A minus j omega. Limits are from minus infinite to 0. So take limit substitution. Upper limit is 0, so e power 0, minus lower limit is minus infinity, so e power minus infinity by a minus j omega. So we know that e power 0 value 1 and e power minus infinity is 0 by a minus j omega. So the result is, what is the result we have? 1 by a minus j omega. 1 by a minus j omega. So this is the Fourier transform pair. So I am writing final result e power at u of minus t Fourier transform is 1 by a minus j omega. Similarly, you can do it e power, for example, 3t u of minus t. What is the Fourier transform of e power 3t u of minus t? What it is? How much? 1 by, in the place of a, what we have 3. So 1 by 3 minus j omega. 1 by 3 minus j omega. Simple, very simple. So here the thing is u of minus t we have to know. Then we can do easily. Right? Let's go to another problem. Find Fourier transform of signum function. Very important. Signum function Fourier transform. Find Fourier transform of signum function Sgn of t. So you know signum function how it is like. First I am drawing signum function, then we go to do Fourier transform. So signum function is very simple. This is the signum function. It has two values, plus 1, minus 1. This is the signum function. So this is minus 1 and this is plus 1. X-axis is t and the signal is signum function Sgn of t. So this signum function we can write using step function. First I am taking that relation between signum function and step function. So signum function is equal to Sgn of t is equal to, so this is u of t, t greater than 0 it is u of t. So u of t, and this one it is left side, so u of minus t, and we have minus 1, so that is why minus. So this is the relation we can take between signum function and step function. Between signum function and step function. So this signum function we can write like this. I am multiplying u of t by e power minus at. I am multiplying u of t by e power minus at, and u of minus t I am multiplying by u of minus t I am multiplying by e power at. Understand here, e power at multiplied by u of minus t, e power minus at is multiplied by u of t. Then after I will apply the limit a tends to 0. If you keep a is equal to 0, as it is we get, right or not, u of t minus u of minus t, same. So we can write signum function like this. We can also write signum function like this. So because already what we are going to do, Fourier transform of signum function. So for the first signum function I am writing in terms of step. Then I am taking this e power minus at u of t minus e power at u of minus t, and limit a tends to 0. So now apply Fourier transform both sides. Apply Fourier transform both sides. So if you take Fourier transform, so Fourier transform of signum function is equal to limit a tends to 0 Fourier transform of e power minus at u of t. I am just taking Fourier transform both sides, nothing else. Then minus Fourier transform of e power at u of minus t, and this limit a tends to 0 is for both the bracket, right? So already we know this, we know it, e power minus at u of t Fourier transform, just before we have done, in the previous session we have done e power minus at u of t. What is the Fourier transform of e power minus at u of t 1 by a plus j omega, right? Minus, what is the e power at u of minus t Fourier transform? 1 by a minus j omega. So this is a step we are taking. Already we know this, we know it, and this also we know. That is why we are writing directly 1 by a plus j omega minus here 1 by a minus j omega, and the limit a tends to 0 is as usual. So now we can apply limit a tends to 0. So apply a tends to 0, 1 by j omega, here minus 1 by minus j omega, right or not? Minus j omega. So minus minus will become plus 1 by j omega plus 1 by j omega. The result is, answer is 2 by j omega. 2 by j omega. Okay, 2 by j omega. Or we can also write 1 by j omega is the minus j. So minus 2j by omega. Minus 2j by omega. This is also same, right? So very important signum function Fourier transform. Just we have written u of t, the signum function in terms of step function. Then we have taken e power minus at, e power at multiplication, and a tends to 0. After that we applied both sides Fourier transform. Then we have 1 by a plus j omega, 1 by a minus j omega, then a is 0. Limit a tends to 0 taken. So this is the result. So Fourier transform of final step we can write like this. Signum function Fourier transform, Sgn of t Fourier transform is how much? 2 by j omega. 2 by j omega. This is the final result. Okay. Now one more important problem we are going to do. Fourier transform of unit step function. Find Fourier transform of unit step function. Unit step function or unit step signal means u of t. U of t Fourier transform. Very important. So how to do it is very simple. By using signum function Fourier transform, we can get u of t Fourier transform. So we know that, what we know, the relation between signum function and step function. So signum function is equal to 2 times u of t minus 1. This is the relation between signum function and step function. Already we discussed it. So I am taking now directly. Signum function can be written as 2 times step function minus 1. So this is the relation we are going to take. This relation will help us to do Fourier transform of step function. So we want step function, right? So step function means, so I am sending that minus sign, then we get 1 plus Sgn of t signum function. Then we want u of t only step function, therefore 1 by 2 plus then signum of Sgn of t by 2, signum function by 2, just 2 I am sending right side. So 1 by 2 is the constant, and the signum function already we know. So apply both sides Fourier transform. Apply both sides Fourier transform. Then Fourier transform of u of t is equal to Fourier transform of 1 by 2 plus Fourier transform of signum function by 2 or SGN by 2, signum function by 2. So 1 by 2 is a constant. So this we have Fourier transform of constant k. Fourier transform of constant k. Or first of all, Fourier transform of 1. I am taking a constant 1. So it is 2 pi del of omega. Fourier transform of 1 is 2 pi del of omega. So Fourier transform of constant k, it will become, how much? It will become 2 pi k del of omega. So likewise, Fourier transform of 1 by 2. So 2 pi k is 1 by 2. So 1 by 2 del of omega. So here 2 get cancelled. Pi del of omega. So this is about Fourier transform of 1 by 2. Now we know Fourier transform of signum function. Previously we have done Fourier transform of signum function. What is the Fourier transform of signum function? How much? 2 by j omega. 2 by j omega. Now, so already we know 1 by 2 Fourier transform, signum function Fourier transform. Let's substitute to get the Fourier transform of u of t. So now Fourier transform of u of t is equal to Fourier transform of u of t is equal to Fourier transform of 1 by 2. How much? Pi del of omega plus, and Fourier transform of signum function. So 1 by 2 is as usual. Signum function Fourier transform is 2 by j omega. So here 2 get cancelled. This is a Fourier transform of step signal. So what is the answer we have? Fourier transform of step signal is pi del of omega plus 1 by j omega. This is the answer. So I am writing Fourier transform pair. So u of t Fourier transform is pi del of omega plus 1 by j omega. 1 by j omega. So this is the result. Okay. So till now we have seen Fourier transform of elementary signals. Elementary signals. Just I am going to write one by one Fourier transform of elementary signals. So first one. So by using this Fourier transform of elementary signals, we can do more problems easily because they are helpful in doing coming problems. So I am just writing the list. So first one, Fourier transform of del or impulse. Fourier transform of impulse function. How much? 1. And just now we have done Fourier transform of unit step function. What is the Fourier transform of unit step function? Pi del of omega plus 1 by j omega. And Fourier transform of this exponential decaying e power minus at u of t. How much? 1 by a plus j omega. 1 by a plus j omega. And Fourier transform of e power minus a mod t. How much? Fourier transform of e power minus a mod t. 2a by a square plus omega square. And Fourier transform of e power at u of minus t. How much? 1 by a minus j omega. Right? And Fourier transform of signum function. Two by j omega. So all these we have done, and these are all helpful further, right? So we can do Fourier transform of u of minus t. Fourier transform of u of minus t. So what is the answer? Fourier transform of u of minus t, folding of u of t. Folding of u of t. So here we have u of t Fourier transform. Now u of minus t Fourier transform. Time reversal of u of t is u of minus t. What is the Fourier transform of u of minus t? So how to do is, so already we know signum function and step function relation, that I am going to use again. Signum function is equal to u of t minus u of minus t, right? So we want Fourier transform of u of minus t. So both sides we apply Fourier transform. Both sides apply Fourier transform. So Fourier transform of Sgn of t is equal to Fourier transform of u of t minus Fourier transform of u of minus t. So this we want Fourier transform of u of minus t. So we can write Fourier transform of u of minus t is equal to Fourier transform of u of t minus Fourier transform of signum function. Right or not? So what is the Fourier transform of u of t? Here available, pi del of omega plus 1 by j omega minus, what is the Fourier transform of signum function? 2 by j omega. So 2 by j omega. Just we simplify. So what is the answer we get? Pi del of omega 1 by j omega minus 2 by j omega. It will become minus 1 by j omega. So this is the Fourier transform of u of minus t. Very, very important. So what is the answer we got? Pi del of omega minus 1 by j omega. So this is the list of problems we have completed till now. So dear students, please watch, share the channel. Very, very useful to you. Thank you. We meet again. Thank you, students.